Okay, so special cases here, going back to Hoy-Vux, and these are nice, easy ones to just kind of process. So if I am got the point negative 2, 6, I want to find something perpendicular to x equals negative 4. Well, if it's x, it means it's going to have an opposite reciprocal slope. So instead of x equals something, it's going to be y equals. And then I just have to identify what y equals in that ordered pair, and that's 6. If I find the equation through 4, 8 perpendicular to 9, y equals 9. Same logic, so perpendicular means I want x equals, and then what is x equal in that ordered pair? That would be 4. Parallel means same slope, so I'm going to keep the variable this time. So instead of x equals 3, I just go to the ordered pair, and it's x equals, well, whatever that number happens to be. And then in the last case, parallel to y equals negative 7. So again, that means parallel means it's going to be the same slope. So what does y equal in that ordered pair? And that would be negative 3. So Hoy-Vuxes are nice, easy to work with. The last topic in this section that we're going to address is how to graph lines generally speaking. So given any type of equation that we're thrown at, how do we go about graphing those particular things? So if we are given information that we can deal with slope-intercept form, then our first step is to identify the slope, the slope and the y-intercept. And then we want to plot the y-intercept, which is going to be 0, comma, whatever number the y-intercept is. So it's going to be an ordered pair that crosses the y-axis at that point. And then, step 3, we want to find the next point using the slope, or rise over run. And then we want to connect the points using arrows. If instead we're given something like standard form, then then I can do one of two things. I can either translate it into slope-intercept form, or what I can do is I can plot the x-intercept by setting y equal to 0. And you're thinking, what would that do? Well, that's going to give me some number for x, comma 0. So that'll give me a point where it crosses the x-axis. And then I could find the y-intercept using the same logic. So replacing x with 0, so I get 0, comma some number for y. And then I just connect those two dots with arrows. So standard form is nice in that you've got what I call the cover-up method, that you can just cover up one variable and solve for the other. All right, so let's take a look at some examples of this. Here we're given y equals negative 3x plus 2. So the slope in here is negative 3. The y-intercept is 2, or it crosses at 0, 2. So I'm going to plot that point, 0, 2. And from that point, I want to go down 3. So 1, 2, 3, and over 1. And there's my new point. And then I want to connect that line. Okay, and the next example, the slope is 3/4. Sorry, I meant to switch to black. All right, 3/4. The y-intercept is negative 3, or means it crosses at 0, negative 3. So I want to plot that. And then from here, I want to go up 3. So 1, 2, 3, and over 4. 1, 2, 3, 4. And then there's my new point. And again, I just want to connect those 2 points. Now, the cover-up method, or the intercept method, is great in that I can very quickly figure out. So one thing I can do is I can kind of cover up that part, and ask myself, if 6x equals 18, what does x equal? X equals 3, because 3 times 18 is 6. And then do the same thing for the negative 9y, which happens to be negative 2. And so I can just plot those 2 points. And then I can connect the dots. Yay. I'll do the same thing. We'll cover up. Okay, so 4x equals 6. That means x is 6/4. Reduce that, we get 3/2. So it crosses the x-axis at 3/2. I'll cover up the other way. That means y equals 6. That was pretty easy. So 3/2 on the x-axis, which is like 1.5, and 0.6 on the y-axis. And connect those points. We're going to pretend that it actually went through that line. And there you go. So not too bad to deal with sloped intercept form and standard form.